Hey, good evening to one and all. Today it's about the embedded firmware design and development. Okay, so an embedded system is a system which is a combination of hardware and software which performs a specific task. Okay, so we are going to discuss about that embedded firmware. So what is the embedded firmware and what is its responsibility? So the embedded firmware is a software and that is responsible for controlling the various peripherals of the embedded hardware and generating the response in accordance with the functional requirements of the product. Okay, so the embedded firmware is usually stored in a permanent memory and it is non-alterable by the end user. Suppose, let us take an example. I want to measure the temperature of the room. Okay, so for that, I need to use a microcontroller. So the microcontroller is having the permanent memory that is called read-only memory. So I need to develop a code and I need to download that code into that permanent memory. So based on the code which is downloaded into the memory, so the system will work. So the designing embedded firmware requires the understanding of a particular embedded product hardware, like the various component interfacing and the memory map details, the IO port details, and the configuration and the register details of the various hardware chips used in a system, and some programming languages, which can be either low-level assembly language or high-level languages like C or C++, or are the combination of the two. So the embedded firmware development process starts with the conversion of the firmware requirements into a program model using various modeling tools. So now we are going to discuss about the two basic approaches for the design and implementation of the embedded firmware. The first one is the super loop based approach and second one is the embedded operating system based approach. So we can choose either super loop based or the embedded operating system based approach. Okay, so that is purely dependent on the complexity and the system requirements. So the first one is the super loop based approach. So this approach is suitable for the applications that are not time critical, where the response time is not at all important. So that means if you want to design an embedded system, if you want to design an embedded system where the response time is not critical, so that means where the missing deadlines are acceptable. So that means even though for a task there should be a deadline, if that deadline is missed, so it can be acceptable. In such cases, you can use the super loop based approach. And this is very similar to the conventional procedural programming where the code is executed task by task. And the tasks are executed in a never ending loop. And the tasks listed on the top of the program code is executed first. And the tasks just below the top are executed after completing the first task. So the super loop implementation will be like this. So initially configure the common parameters and perform the initialization for the various hardware components like memories, registers, etc. Start the first task and execute it. Execute the second task, execute the next task, and so on. Execute the last defined task, and again jump back to the first task and follow the same flow. Suppose if there are 10 tasks, initialize the parameters, start the first task, execute it, start the second task, execute it, and so on. Execute the last task, which is nothing but task 10 here, and again jump back to the first task and follow the same flow of execution. So this type of approach is called super loop based approach. Okay. So the pros, advantages here are doesn't require an operating system for task scheduling and monitoring and free from the OS related overheads. And simple and straightforward design and reduced memory footprint. Okay. And the disadvantages are non-real time in execution behavior. So we are expecting a real time behavior from the embedded system. But if you design a system with a super loop based approach, so we are not expecting the non real time behavior. Okay. Any issues in the task execution may affect the functioning of the product. That is another drawback. The enhancements will be it combine the super loop based technique with the interrupts, okay, and execute the tasks which require real time attention as interrupt service routines. So the interrupt service routine. What do you mean by interrupt service routine? It's a program which is related to an interrupt. So what is an interrupt? It breaks the normal activity of the execution of the CPU. Whenever an interrupt occurs, what the CPU will do? The CPU will stop the execution of the current program. The CPU controller is transferred to the interrupt program that is called interrupt service routine. Now the CPU starts executing the interrupt service routine. At the end of ISR, the CPU goes back to the interrupted program at the point of interruption. So this is called super loop based approach. Next one, embedded operating system based approach. So the embedded operating system based approach in this, okay, so which can be the embedded operating system. So that means we are going to use the embedded operating system, which can be a real-time operating system or a customized general purpose operating system. So the embedded OS is responsible for scheduling the execution of the user tasks and the allocation of the system resources among multiple tasks. If there are limited resources, if you want to execute multiple tasks, so the embedded OS is going to share the system resources among the multiple tasks for the execution of user tasks. It involves a lot of OS related overheads apart from managing and executing the user defined tasks. So the Microsoft Windows XP is an example of GPOS, and the Windows C, the Windows Mobile, VxWorks, Micro C or OS2, embedded Linux, Symbian, etc. are the examples of RTOS employed in embedded product development. Symbian is an example of the operating system used in your Nokia mobile. So this is about the two approaches which are used for the embedded firmware design. One is the super loop based approach, and second one is the embedded operating system based approach. So that's all for this video. Hope you understand this video. We'll meet in the next video. Thank you.